Oh no! Get on there. I'm gonna break that poor little leg. Alright guys, I think last time we got through section 3.5. Believe it or not. If you were here, you should believe. If you were here, you saw it happen. We're about to get into 3.6, and that's the one I turned the pages, wrote at the top of the page, the equation of a line, which most of you guys should probably know by now. If you don't, go over the parts of it, explain to you why the M is what it is, why the B is what it is. Okay. Try to. Always try. And in fact, before we do these, this is a little too, I want to explain why things are what they are. So, let's start off with like y equals 2x. So can you guys make a table of values for this? Let me actually give you some stuff here. Should be relatively quick. Where are you at? Alright guys, so you can always kind of step back, believe it or not, and look at something a little less algebraic and competition. I mean, what does that say? The y piece is double the x piece. That's all it says, right? Whatever the x piece is, the y piece is double it, right? So let me ask you this question. Let's fill this out and then ask you a question. What is double -2? That's crazy. Okay, so it just doubles all those. I like it. Can you guys see the Y-intercept? It's right there, Jeff. I like that. Yeah, you could have just went, yes. Yes. What's the Y-intercept? 0. Right, 0, 0. I like it, I like it. Now stay with me, stay with me. Well, guys, if the equation says whatever x is, I double it. If x changes by 1, how much should y change by if I keep doubling everything? 2. It's crazy. It's insane. So, sure enough, look what happens. What did x change by from -2 to -1? How much did x change?
1.
By 1. It increased 1. And sure enough, what did the y's do? They increased by 2. It's insane. So the idea that the number in front of the x is the slope should not be too surprising, because what we just did was the slope, isn't it? How much did the x's change by? 1. How much did the y's change by? 2. Slope is 2 over 1. So where in the equation do I see that? Right frickin' there, of course. Whatever x does, y is double that. So if x changes by 1, y will change by 2. 2 over 1, that is the slope. So I always call that the number sitting in front of the x the amplifier, or the multiplier, or whatever the hell. Right? Whatever x does, y changes by that times what the x did. Right? And that's what the slope is all about. The slope is when x does something, how does y react? In this case, y is double whatever x does.
So if it's ever the 2, whatever's in front of the x, that's what the slope will be?
Beautiful. Beautiful. Right? Now what if I do this? This is 1, 2. Let's make that same table of values for this. All right, so take a minute and try to fill that table in. and put a negative 2 in. Double negative 2 is
-4.
negative 4 minus 3 is
-7.
negative 7. Put a negative 1, you get negative 2 minus 3, negative 5. Put a 0 in, you get 0 minus 3. That's crazy. Put a 1 in, you get 2 minus 3. Amazing. I like it. Now notice a few things that if you don't quite see this, it should immediately become very obvious. How do these two relate? This is 2x and this is 3 less than 2x. So it shouldn't be surprising that every output for this guy is 3 less than they were up there, because it's 3 less than what this guy was. What's this guy's y-intercept? 0, negative 3. And why does that make sense? Because normally it would be at 0, 0, 0, but I took and made everything go down 3. In fact, if I put a 0 in for x, whatever this number is going to be the y-intercept. That's what's going to be left over. That's how you find the y-intercept. You make x 0. Now look, if my theory from earlier still holds, I don't care that the minus 3 is there. Every time the x changes by 1, the y should change by 2. So see, when the x changes by 1, the y's went up by 2. I like it. So the minus 3, all the minus 3 does is it takes the line and moves it down 3. That's really all it does. It takes all the outputs that were there before and takes 3 away from each of them. So it just moves the line down. So that's why that piece is the y-intercept. The slope being 2 means whenever the x changes by something, the y is going to change by twice that. That's exactly what slope is. How much the y changes over how much the x changes. Okay, let that make sense. So what we're saying is, whatever this number is the slope because it's the multiplier of what x is doing to tell you what y is going to do in response. And whatever number is here, I didn't even need to do all that really, because how do you find the y-intercept? You make, how do you find the y-intercept? You make x 0. So what do you get for the y-intercept? Whatever b is. So that's the y-intercept. 0b is the y-intercept. That's it. So it's not like amazing. It's not like you'll never get it. It's just that's the way this works. So let's do one more that's not quite as obvious. Stay with me now. Somebody's already deeply sighing. Hold your deep sighs until later. Let's see. I guess I think, yeah. Ooh, the bright yellow paper. Yeah. So, that is kind of bright. What if I had y equals negative 2/3 x plus 5? That looks so yummy. I know, I'm the only one in here that would say that right. Let me see you guys, this is going to help you guys out about creating a table of values, being smart about what you pick. And I really want to make sure you understand this. When you make a table of values, those are just a few points. How many points does a line actually go through? Infinite number. That's why you can choose whatever x's you want to. It doesn't, as long as you find a few, you've got the line. So if you find one that's like 3 comma negative 80, don't use that one. Right? Don't plot that shit. Find a better point. Because there's an infinite number of them. Find a better one. Some of you guys are trying to go and make more of the grid off the... no, don't do that. Don't do that. Just find someone that actually fit. Or change your scale if you really want to use that one. So watch this. What's a really smart number? What's always a smart number to put in for x? 0. Oh, yeah, exactly.
Oh, sorry.
You're good. So what do you get when you put 0 in?
5.
5. And of course, this point is the y-intercept, which you can see from b. I like it. So I don't even have to do any work to know that 5, 0, 5 is the y-intercept because it's in the right place, plus b. Now, like you said, I'm not going to use 1 or 2. I'm going to use multiples of 3 so that these will actually reduce. So if I put a 3 in, what's negative 2/3 times 3 plus 5? What happens here? Yeah, those cancel. What's negative 2 plus 5? 3. I like it. Now right here, let's just, I can keep going. I use 6, I can use negative 3, all that kind of business. And watch this. How much did the x change by here? 3. And how much did the y change by from 5 to 3? Yeah, good. 3, negative 2. It went down 2. So down 2 over 3, down 2 over 3. Right? The slope is negative 2 over 3. It's rise over run. Okay, I like it. Some of you guys look remarkably bored. I know what the hell m is. Okay, it's not. In my experience, very few people I've ever seen explain fully why the hell it is what it is. Just whatever number's there is a slope. What? Don't believe that shit. It should be like, why is it? All right, let's go back. Well, that's pretty good. Let's start here first. Let's go to the bottom of the page. We'll come back up. I don't like the order they did this in. So this first equation, and remember y equals mx plus b. So what is the slope?
2 over 1.
I like it. 2 over 1, or you could just write 2. Either way. That's the one we just did all to that first. And what's the y-intercept?
0.
Is everybody cool with that? Whatever number is there at the end, the plus b, that is the y-intercept. I like it. So another example before we go to this next one. If I had y equals 7 over 11x minus 2/9. You hope to God I don't say graph this, right? So I'm going to say graph. No, what is the slope? 7 11. 7 over 11. And what's the y-intercept? 0. Whatever the hell's there. Oh, so again, everybody's cool with the fact that the y-intercept starts with a 0, right? 0 comma something, which means that x is 0. If I make x 0, what do I get for y? That. Whatever the hell that is, when I make x 0, I'm going to get y equals that. That's it. Don't make more out of it than that. When you make x 0, you get whatever's in the place of b. Okay, whatever that is. That's why that is the y-intercept. Math people being very creative people. We said, okay, I know the y-intercept and the slope, so I'm going to call this slope-intercept form. That is the official name of that form. It's called slope-intercept form. And you'll see that in the title of the section. It's amazing. So what's wrong with this second question then? What's kind of wrong with the way it is? Why is not myself? So it's really kind of freaky. When you first do this, when you solve for y, everything falls into place. It's a little bit difficult to believe. Now this is a little early to really get into this, but I just want to tell you, eventually in your math career, you're going to learn the equation of a circle. And when you put the circle equation in a certain form, what are the most important parts of a circle? The radius. Diameter. If I know the radius, I know the diameter. So there must be something else. No, if I know the radius, I can calculate the circumference. So what else do I need to know besides the radius? Well, the radius is how far it is from the... so I got to know the center and the radius. Once I know those two things, I got the circle, right? So what if I want a circle over there? All right, well, I'll make my center there, tell you my radius, and then I make a circle there. So if I knew the center and the radius, I could draw the circle, whatever the hell it is. I just go to the center and then go out from the center so much, make my circle. Are you guys with me? So the equation of a circle, when you put it in the right form, you can see the center, you can see the radius. It just comes out at you. Just like if you put a line equation in the right form, you can see the slope, you can see the y-intercept. This kind of idea is beautiful because it should line up. A circle has an equation. The equation makes a table of values that you can plot a circle with. The equation should show you information about the shape you're dealing with. And a line is a pretty simple shape. So here, how do I get this? What do I do? And here you got to be careful. If you do this, it's not very helpful. So what's a little bit better way to write that? Yeah, there's even a little bit better way. Negative 1/3 x
Plus 4/3.
plus 4/3. I like it. So what's the slope?
Negative 1/3.
Negative 1/3. And what's the y-intercept? Careful. 0 4/3. I can almost hear the person on the line. Whatever. All right, I know I try to make a big point of this because it saves you from making silly mistakes if you remind yourself the y-intercept is a point in itself, not just a number. You won't make silly mistakes about that. And remind me, what's the slope tell me? In this case, I would go down 1 over 3. I like it. So now, this is why I like doing this before what they have up here. Just to show you, I mean, if I go through the point 0, negative 2, and have a slope of 3, where do I start? How do I graph that line? Good, beautiful. The slope tells me if I start on the line and I do what the slope says, I'll get back to the line. So don't start at 0, 0 or something crazy. Plot 0, negative 2. And then it's got a slope of 3, so I go
Up 3
over 1. Right, it's 3 over 1. And then, that's it. You put a little, let's see, I need help. You do it, Jeff. Pretty close. What would the equation of this line be? What's M?
Negative 2 over 1.
Careful, what's M?
3.
3. M is the slope. What's B? Good. B is the y piece of the y-intercept. So what's the equation? It would be y equals 3x minus 2. Bam! I like it. That's emerald math. So obviously, hopefully, if I can pick off the slope and y-intercept from an equation, I should be able to do that backwards. If somebody gives me the slope and the y-intercept, I should be able to put the equation together. Not too evil yet. So do the next number 1 real quick. No better. This guy wants us to do good. Shit's out. Do it again, sorry. It's going to be in the second quadrant. Oh, well, I mean, it goes forever in both directions, so. Oh, interesting. Well, there's an infinite number of points.
As of right now, how much do you want to do it, right?
No. Sorry. I see what you mean, but not quite. I'm sorry. Yes?
So, because it's negative, do we go down 3 to the left too? Or down 3 to the right too?
Ah, okay. All right, here we go. Math says negative 3 halves is the same thing as negative 3 over 2 is the same thing as 3 over negative 2. So math itself, computation, would just go, why'd you write that 3 times, dude? It's negative 1.5. I don't care what the shit you do with it. But what's the difference between this and this slope-wise? This says go down 3,
to the right.
positive 2, right? And this one says go up 3, back 2. Yeah. So you should be able to go both on a line. It should go up and over or down and back. I should be able to do both and still have the same line. You could do it either way. Let's try it. We'll do it both ways. So y-intercept of 2.
0 to.
Beautiful. I was going to say, what's wrong with the way they wrote that? I got to remind these people, hey, we're better than this. 0, 2. Now let's try it this way. Go down 3 over 2. Let's try the other way. Up 3, back 2 on the same line. And again, if I do it this way, watch. Stay with me now. Down 3, back 2. How do I get back to that point? Up 3? Back 2, right? I mean, it's, of course it's got to work both ways. Okay. I love it.
I was going.
See your board faces. What's up? Yes?
Because I was going down 3 and then to the left 2.
Oh, yeah, they're not both negative. If they were both negative, then the slope would have been positive.
So we can choose.
If you go down 3 back 2, what's your actual slope going to be? Positive 3/2. But the slope is negative 3/2.
We can
I like it.
choose to do that.
You can put the negative on the top, or you can put the negative on the bottom. Don't do both. Yes?
So to write it like the y equals, plus b, would it be y equals negative 3 over 2x?
Maybe. Hold on. Notice also, what's a quick way you can make sure that you didn't make a mistake like that? Slope's supposed to be negative, which means the line should be going down. Thank God it is. What would the equation of this line be?
Y equals negative 3 times x.
Good. Slope times x plus 2. Cool. Did they ask for that in this? I don't know. They didn't. I don't care. All right. Stop there for a minute. You need to figure out if majority of you really know this stuff really well, or if you're like, oh yeah, this is the part where I just turn off and hope to God I got enough other shit to pass. I don't know what's happening up there. Let's see. I guess I'll find out very soon. All right. Here, and now this is interesting. Do 3. 3 is still fine slope and y-intercept. Definitely do 3 and then try to do 4.
What are we doing? That's finding this.
Find slope and y-intercept, yeah. Do 3 and then try to do number 4. I'm trying to let you know if 4 freaks you out, there might be a good reason for that. Guys, what are you doing for number 3?
You subtract negative 2x.
So what's the general idea for
Getting y by itself.
getting y by itself? Anybody else? The rest of you guys have like vocal cords and shit. The ability to speak. Right? So let's see. So if I solve this for y, I'll put it into the right form. Everything falls into place. So yeah, subtract, what would I subtract? 2x. And this is where we'll force that in front. So we'll have it in the right form to begin with. And then of course, what do you do? Divide by 4. So you get, what do you get here?
Oh.
Yeah, negative 1/2x.
I just kept the 2.
Plus 5/4. Oh yeah. Oh yeah. Anywhere in the universe you see 2/4, you can make it become 1/2. So the slope is
Negative 1/2.
Careful.
Negative 1.
Slope is negative 1/2.
1/2. Negative 1/2.
Yes.
0, 5, 4.
0, 5, 4, so M is the slope. B is the y piece of the y-intercept. Real quick, I want to show you something. Because you're sitting there thinking, I've gone through this line shit before, what good is it? Alright. Here's my house. I have a little anti-ballistic missile defense system outside my house. Right? Most of it's on the ground. And I disguise it as a tree stump. Right? So, Kim Jong-un finds out about me and he says, he doesn't like Dennis Rodman, I'm going to kill him. So, you guys know about Dennis Rodman? So he shoots off this thing. Now this thing is moving with a certain trajectory. Now I want you to realize something. Stay with me now. I'm going to try to show you why it's important to know slope. It'll save you one day if you happen to have a tree stump that's actually missile defense. But also, it's how we do anything when we try to intercept anything, right? So we had our Patriot missiles back in the day with when we went into Iraq and all kind of stuff, and we had the Scud missiles and stuff, and then they were trying to intercept those guys. So I have an equation for this, and then when I shoot my defense off, I want to set the equation so that it will intersect with this one and blow it up before it blows my house up. So that would be like maybe about 7 levels up from where we are now, but still, it's the same exact freaking idea. I want to know how it's moving and where it is at a certain time. Then I'll know where it's going to be, and then I can program mine so it will hit it. And of course, as mine's traveling, I can kind of change its equations if I needed to. If this guy started to wobble or they change theirs, I'm going to change it. You guys kind of get the idea? I mean, no, not at all. So again, if something is moving in space, there's an equation that tells me where it is and where it will be. Now, we're dealing with things moving in straight lines in 2 dimensions. Right? Okay, the real world, 3 dimensions, it can move in all kinds of swirly ways. The idea, though, is the same. There is something that's actually related to slope, even if it's not a straight line. And when I shoot mine off, I want the equation for this to intersect the equation for this at the right time. And I know a computer does all that shit, but who programmed the freaking computer? Humans, right? You guys see what I'm saying? So you can sit there and go, well, I'm not the one that's going to be shooting the missiles down. Or you can go, I'm a part of the freaking human race. I probably should know some of this shit that, saves people's lives. I mean, that's just one possible example of the use of equations like this to know the slope. What could you do with it? You could do this. That's an awesome picture. All right. My little house with no doors or windows. Who's got number 4? What would this thing look like? Who remembers? Vertical line. This is the y, this is the x. What's the y-intercept? Anything. No, not anything. Did you say anything? Where does it hit the y-axis?
Never.
It always goes straight up and down. The only way it could hit the y-axis is if it came at an angle to it, right? I mean, it's always following the y-axis. In fact, we call that what kind of lines? Parallel. So x equals a number is always going to be parallel to the y-axis, unless it is actually the y-axis itself. But it won't have any y-intercepts. It does have an x-intercept, though. And it tells you in the equation, x-intercept is going to be negative 2, 0. Right? But it won't have any, there's no y-intercepts. And what's the slope?
There is no slope.
Well, there is, well, sort of, but it's officially called infinite or undefined. Like it's one of those that just goes straight up and down. That's where the instant transmission came in. So remember what I said earlier about x equals and y equals are special cases. If you try to force them to act or you try to look at them the way you do regular, everyday lines, it's not going to be easy. If you just go, oh yeah, it's a vertical line, no y-intercept, undefined slope, they're the easiest ones. But if you try to force it to work like number 3 did, you're going to go a little crazy. Okay. Can you solve this for y? And there's no y there, so it breaks down immediately, and then people go, well, what the hell do I do? This is easy. It's a special case. You got to remember what it looks like. So what about y equals, if I had y equals 2? Horizontal line, what's the slope? No. 0. It's flat.
Oh.
0 slope. Rise over run. Well, how much does that line rise? None over however much run you want. 0 over something is 0. So slope would be 0. What's the y-intercept? 0, 2. KCAS. The problem tells you, right? 0, 2 is the y-intercept. So that's the other special case. The horizontal line. Vertical line, horizontal lines, special cases. If you try to force them to work like any other line, it's not going to be easy at all. Just remember, it should be one of the easiest questions. You got to remember that. Okay. How are we doing? Oh, good. We got plenty. All right. I think we already did one like this, didn't we? I can't remember. Maybe we did. If I want to graph this, what's the y-intercept? I don't have to make an xy table anymore. 0, negative 5. That's a good starting point. And the slope is 2 over 1. I love it. So I start at 0, negative 5. And I go up 2 over 1. Up 2, over, up 2. As much as you want. Yeah, that's enough. Ooh, that's pretty good for me. Real quick, how do you check this? You get a graphic calculator. No, screw it. I'm not going to let you use those.
Pick a point.
Yeah, so what point is this?
3, 1.
If we did this correctly, what should be true about that point? It should work. When you put a 3 in for x, 2 times 3 is 6, minus 5 is? Thank God. You guys see that? Yes?
I have a question on how you can tell which way the arrow is going. Is that arrow going down or is that arrow going up because the slope is going up?
There's 2 arrows. This arrow is going
Yeah.
this way, and this arrow is going down, just so the line keeps going in both directions. How do you mean?
Maybe we'll get it. Yeah, no, I thought that there was like, you could tell if like it's a negative or a positive line. Yeah, it's.
So as you read, it's going up, so it's going to be a positive slope. Yeah. So it matches with the fact that it's got to be a positive slope. I like it. All right, so you guys do this one. While you guys work on that, I'll remind you there's a quiz in lab today and tomorrow. Whatever lab time you got. Yay! You want more grades, trust me. All right, guys, so what's the y-intercept here?
0, 3.
0, 3, I like it. So we start at 0, 3, and I go, yeah, so I could go down 1 over 2, down 1 over 2, or I could go up 1, back 2. Either way I do it, I've got the same line here, right? Let's see if I got it. Oh my gosh. Okay. Sort of. Almost straight. So if this was the path of a missile, I keep going with missiles, but oh well, then it would hit the ground somewhere over here. I mean, that's, that's an immediate thing I could do with the graph. Right? Hopefully not near us. Let's see, blah, blah, blah. Oh. All right, so they give you the graph of a line. They ask you to write slope-intercept form of the line. So let's see what you can do. Try this. This is basically backwards from what we just did. You get the equation from the graph. This is a know it or you don't situation really. What's the value of B?
0, 2.
No, B is 2. B is the y piece of the y-intercept. So B is 2. What's the slope?
-1 over 2.
Yeah, down 2 over 1. So it'll be -2 over 1, -2. And now I just got to throw those in the right place. So what's the equation? Yeah, -2 x plus 2. I love it. Whoops. Just make sure you guys realize something. If I gave you this, what's the slope of that one?
0.
The slope is -11. Right? It's not the first number you see. The slope is the number in front of the. Some fool, me, wrote this backwards. I wrote it in B plus mx. Right? So the slope is -11 over 1, and the y-intercept is 0, 5. Take out. So that's why I meant earlier when I said try to force that x piece when you subtracted that 2x. Force it in front. So you put it in the right form so you don't make a mistake like that. I like it. Well, you guys are ready to go. So I'm going to do one more. Oh, cool. So let me ask you this. What do you think is true about two lines that are parallel? What do you think is true about their slopes? They have to be equal to each other. Does that make sense? If they were going to run into each other, one of them's got to be climbing faster than the other one. Okay, that makes sense. So if they are parallel, the slopes have to be exactly the same. Now, who remembers what perpendicular means? Yeah, they make what kind of angle? 90-degree angle. So I don't mean they just intersect. They have to intersect so they hit at a 90-degree angle. So what's going to be true about the slopes here? This is kind of weird. Now, obviously, if one is positive, the other one's got to be... Does that make sense? If they're both positive, they're just going to hit somewhere maybe if they're not the same. You guys, if one's going up, the other one's got to be going down. That's just all there is to it. That makes sense. The part that doesn't make the most sense is that not only do the signs have to be different, but if one slope is 3, the other slope has to be -1/3. So parallel lines have the same slope, but different y-intercepts, so they actually are not the same line. Perpendicular lines, I hate the way they say this, and I hate the way they say that too. Negative reciprocals. Opposite reciprocals is kind of silly because reciprocal is a type of opposite. So one slope was 1/7 the perpendicular slope would be negative 7. Or 7, no, 1 second. I like it. Let's see, do I have a spare? Yes, I do. I'm going to hijack this guy's graph real quick. Last thing we're doing today, if anyone's curious. Page 51. We didn't do this problem, so it just goes. Too bad for you, problem. I'm going to hijack a graph. Alright, let's try to graph these two things and just kind of see if they look like they're perpendicular. So perpendicular means they hit each other but at a 90-degree angle. So how do I graph 3x minus 1? What do I know about that line? Yeah, so I go down 1, start there, and then what's the slope tell me to do from there?
Up 3 over 1.
Yeah, up 3 over 1. So there's that line. Not too bad, Jeff. It could be better. Oh. What do I know about this line here?
0, 2.
Yeah, it starts at 0, 2, and I go down 1 over 3. So then that one would be like this. I like it. So that does sort of look like it could be 90 degrees. Now, if I would have just made this the opposite like this, negative 3x plus 2 instead, we do this in, well, that's all you gave yourself, Jeff, is black ink oil. If I would have done this instead, I want to show you. If I just made it the opposite sign, it would have went down 3 over 1.
You mean, okay, so you just meant to write 1 right there, not 2.
No, I meant to write 2 right here. Yeah. Starting at 2, down 3 over 1. Would that have been perpendicular? That doesn't look like a 90-degree angle there, right? No. That doesn't look like a 90 degree. It's not perpendicular. Anything up there. So they have to be, that's why I like to say parallel have to be exactly the same. Because perpendicular have to be completely opposite. And how many opposites do we know? Change the sign, flip it. You do both. I love it. Alright. So whoever's got lab, I'll be over there in a minute. We'll do that quiz. Say again? Sorry?
Last week I gave you my picture.